Okay, now we're gonna work this problem. This is a improper integral of the second kind. So the bounds seem like finite, but they have an issue with the function. So here we're integrating on zero, but we have zero problem here. Okay, we also have an issue here on the natural log of x when x goes to 0. Okay, so we have a problem here in this value here. So that's the second kind of improper integrals. Okay, we can solve this one by just taking the limit as x goes to 0 plus of this integral. Let's call it between x and 1 of ln of t over square root of t dt. Okay, so we removed this problem, okay, on 0 by integrating on x 1. So now we're gonna let x approach the 0 from the right, okay, and we see if this one is finite or not. If it is finite, the integral exists. If it's not, then it's divergent. Okay, so the best way to get rid of the square root here is to define a change of variable. Let's call square root of t as y. So we have dy is 1 over 2 square root of t dt, and this is just 2y dy. That means dt is this value. Okay, so the other issue is that we need to change the bounds, but we would have no problem. So when t is x, okay, y is going to be the square root of x. When t is 1, y is going to be 1. Okay, now the natural log of t is just y squared, and the square root of t is just y, and dt is going to be 2y dy. Okay, now going back to our problem, we have to integrate this one. Simpler problem by using this change of variable. So it's going to be the natural log of y squared, but using the laws of the log, we can take these two with this y squared. The square is going to be 4. So we have the natural log of y dy. Okay, we know a primitive of the natural log. Okay, because we know that one it's ln of x. We can do integration by part. It's going to be x ln of x minus 1 plus some c. A simple integration by part here, 1 times this one. Okay, so we get the limit as x goes to 0 plus of this one. So it's going to be y ln of y minus 1 between square root of x and 1. We compute this limit, this value, and after that we take the limit from the right. So let's do this. So the limit as x goes to 0 plus. So now we're gonna have, I forgot the 4. Let's have the 4 here. So I have, when I plug 1, I get minus 4. When I plug the square root, I get minus square root of x, ln of the square root of x. Okay, so that's what I get. So when I plug the 1 here, I get 0. Or I have a minus, so that's why I get the 4. Now the limit here is minus 4 minus this limit as x goes to 0 plus of the square root of x, ln of the square root of x. So this one wins. It's a power. It wins versus the log. Therefore, this limit is 0. Therefore, our integral is minus 4. So therefore, this integral is convergent and it's equal to minus 4. Okay, this is a second integral of the first kind. Okay, so we can graph it and we see that it's negative because it's here. Because we're integrating between 0 and 1, and the function is here. If you graph the function, you're going to see it that's here. Okay, and the value is negative. so it's under the x-axis. Anyways, so this is an illustration of how we can compute an integral of the second kind using the definition. Thank you.